So welcome you all in the context session 9 here. And in the question in the context session 8, we have discussed the normal distribution in the continuous. So we have done the continuous random variable, its PDF, its CDF, its mean, expect variance, and then we started the normal distribution. In the normal distribution, we have also done the normal approximation to binomial distribution. So after that, now we are starting. This is the section 5.4. So now we are starting section 5.5 in your according your textbook, uniform distribution. The random variable x is said to have an uniform distribution with parameter alpha and beta. So there are two parameters in the uniform distribution, that is alpha and beta, and the density function is given as 1 upon beta minus alpha, where x is between alpha to beta, otherwise it is 0 here. And the CDF function can be written as x minus a alpha upon beta minus alpha in this range of alpha is less than x is less than beta. I'm not getting you, Mr. Santosh. Up to EC2 syllabus, please. Mr. Santosh, actually we are already behind according to the handout. Okay, our syllabus is not able to come. We are not able to complete the syllabus because we are going in a very slow pace. So if you are today, I will just leave you up to the EC2 syllabus. Then at the end, it's very difficult to uh, complete the whole syllabus actually. Okay, so that's why we have to do some part of the joint distribution. Not so much, but some part we will do it. Okay. So this is the capital Fx as a CDF x minus alpha upon beta minus alpha in the range of alpha. X is between alpha to beta, and otherwise x greater than beta, then it is equal to 1. Okay, the mu is equal to the expected value of x. Formula is same if you want to derive it, but there is no derivation here. Basically we are using direct formula. So expected value of x is equal to alpha plus beta by 2, and sigma square is equal to variance of x is equal to beta minus alpha by 2 whole square by 2. Yes, half of this class is included definitely. So variance of x is equal to beta minus alpha whole square by 12. Okay, and you now know the formula here. Expected value of x is equal to what? Integration from minus infinite to infinite x into fx dx. Okay, so you can use it here, the formula alpha to beta, because in that one the density function exists, x into 1 upon beta minus alpha dx, and beta minus alpha is constant when we are talking about in the terms of x. So it is 1 upon beta minus alpha, and we are getting the condition x square upon 2, and the range is what? Alpha into beta. So that's why we are getting here 1 by 2 beta minus alpha, and that will become beta square minus alpha square. So that will, we can say here, beta minus alpha beta plus alpha upon 2 times of beta minus alpha. So this is cancel out. So here it will become here beta plus alpha by 2. Okay, so that is the derivation I am just trying to say here, that we can also derive any type of formula by using the basic definition which we have done in the section 5.2 to calculate the expectation of mean, variance, expected value of x square and so on. All definitions are same. Okay, but it is a specific density function. That's why we are having the specific mean and variance which we can directly use it. Now one question we are doing here, in a manufacturing process, the error made in determining the composition of an alloy sorry, is a random variable having the uniform density with the alpha is minus 0.075 and beta is 0.10. What are the probabilities that such an error will be between this and this? So what we are doing here, so this is question number 5.46. X follows the uniform distribution with minus 0.075 and beta is what? 0.10. Okay. So we can say the density function will become here 1 upon beta minus alpha in the range of alpha is less than x is less than beta. So we are using the same concept. Fx will become what? It is 1 upon beta is 0.10, 0.10 minus minus plus 0.075 in the range when it is become minus 0.075 is less than x is less than 0.10, otherwise it is 0 here. Okay. So it will become here fx is equal to, we can write like this one, fx is equal to 1 upon 0.175 in the range of minus 0.075 is less than x is less than 0.1 here. Correct. Now after that we are just finding the probability between 0.050 and 0.001. Okay. So in this one, what there are two methods you can use, yeah, either by the density function or CDF. Okay, cumulative distribution function, which you also know about this one, the cumulative distribution function. Okay, so we can use the cumulative distribution functions, and it is given fx is equal to x minus alpha upon beta minus alpha in the range when alpha is less than x is less than beta. है ना? Otherwise x is greater than equal to 1 and it is 0 when x is less than alpha. So what we are using the same thing. So we have to find out the probability that 0.050 is less than, or that is, I will write it like this one, 0.001 is less than x is less than 0.050. Okay. X is greater than beta, greater than equal to beta. Here x is less than equal to alpha. Yes, Mr. Sanjeev, x is greater than equal to beta. Okay. So we have to find out this one. So by using the CDF concept, we can write that f of 0.050 minus f of 0.001. Both are coming in the range of alpha and beta. So we can use it like f of this x minus alpha upon beta minus alpha. So that is what x is 0.050 upon minus alpha. Minus minus plus 0.07 क्या था? 0.075 divided by 0.175 minus minus sign with the f of 0.001. So it is 0.001 plus 0.075 divided by 0.175. Okay, when we are calculating it, we are getting the same answer, that is 0.050 minus 0.001 upon 0.175, and that is become here the same thing. The difference always is coming same. So that is coming same, and that the answer is coming 0.28. You can calculate it very. Okay. Similarly, you can calculate the second one, probability when x is between 0.001 to 0.008. So by CDF we can use directly, because we know the direct formula for CDF and it is very easy to calculate. You can also use the PDF, no problem here, but that will just. So you can use the PDF, but in that one you have to just use the more calculations. That's why we are avoiding it, and we can use directly the CDF also. Okay. So if it is given in the question that you have to use the PDF or CDF, then you can use directly this one. Please repeat what. Okay, no voice, no voice, no audio. Again, there is no audio. Are you not getting my voice? Now, okay, okay, fine. Thank you. So what you want to repeat? Repeat is what? We have to find out this probability. Clear? Explain 0.175. It is beta minus alpha. 0.125. Where it is 0.125? Mr. Rudresh, what is 0.125? I am not getting wherever it is 0.125. It is 0.175, and 0.175 is what? This is 1 upon beta minus alpha. So 1 upon beta, beta is 0.10 minus alpha. Alpha की value it is minus. So minus of 0.075. So that will become 1 upon 0.10, minus minus will become plus 0.075. So that's why 1 upon 0.175. I didn't use here 0.25 anywhere here. Okay. So now we are just saying here f of this minus f of this. So again it is what? X minus alpha and x minus alpha upon beta minus alpha. You can see here the formula, x minus alpha upon beta minus alpha, and 1 when x is greater than equal to. On the slide is coming here like this one. Just adding this part. It is 0.125 and this is 0.0076. On the slide. Okay, thank you. Okay, on the slide. Okay, I'm just thinking from this one notes. So on the slide is 0.25 is what? 0.050 plus 0.075. That is what? X minus alpha. X minus alpha upon beta point. This is 0.050 minus alpha, and alpha is minus, so it will become minus minus plus. Similarly here 0.001 plus 0.075, so it will become 0.076. You can use the same formula here we are using directly, and you can find out the same answer, 0.28. Okay, similarly in the second part, don't be confused from it. Okay, you can just say, okay, look, now it's okay. We are using the formula here, x minus alpha upon beta minus alpha. So x is what? 0.05. Okay, alpha is what? Minus 0.075. Okay, so we can use this 0.05 minus of minus 0.075. Clear? So in the second part also, what we are doing, probability when 0.001 is less than x is less than equal to 0.008. So we are using here the same x minus f of 0.008 minus f of 0.001. Correct? Now we are using the same formula. That is what? 0.008 minus of minus 0.075 upon 0.175 minus 0.001 minus of minus 0.075. Correct? 0.17. Now it's correct. Now you got the formula. So that will become here minus minus plus. So we are just plus it. 0.083 minus, when we are just adding 0.076 upon 0.175. When we are solving this one, so 0.007 upon 0.175, we are getting this answer, and that is 0.04. Mr. Damodaran, I told you 0.175 is beta minus alpha, and alpha is already negative, so we are adding it. We have done it, that part. Okay. Now the next question is the gamma distribution. You can do that part also, no problem. Yes, in the denominator is beta minus alpha. So minus minus, then it will become plus. The next distribution is the gamma distribution. A random variable x is said to have a gamma distribution with the rate parameter alpha and beta. Again, here there are two parameters. Okay, so the density function is given by fx as 1 upon beta to the power alpha, and this is the gamma function of alpha. And because of this function, gamma function of alpha, this distribution is known as the gamma distribution, x to the power alpha minus 1 e to the power minus x by beta. Okay, for x is greater than 0, alpha is greater than 0, and beta is also greater than 0, otherwise it is 0 here. Okay, so gamma function of alpha is the integration part basically for the exponential. Okay, how you can remember the formula? Actually, for gamma distribution, so many formulas I can do. I can understand this so many formulas, and the closed book examination it's difficult to do it. Okay, I will try to find out some solution for that. Okay, there is no other way to remember it. You will just make a one list. On the slide also I just mentioned some important list where we are mentioning the density function, their mean and variance. Okay, on one slide it is given, you can just go through it and you can find out it very easily. Hint, uh, okay, we will see what we can do it. Okay, so this is the gamma function formula for gamma function of alpha. It is a gamma function where this is like this one. But if alpha is any like it is that formula is alpha minus 1, gamma function of alpha minus 1. But if alpha is, Mr. Damodaran, this is not possible. At least I will just give you the 5 question, and from that 5 question only I will ask in the examination. Authority will not allow me. This is not a good practice actually. Okay, so gamma function of alpha minus 1, when we are just doing the same thing actually, so it will become alpha minus 1, again alpha minus 2, gamma function of alpha minus 2, and that's we are going up to the 1 here, and gamma function of 1 is become 1 basically, so it is become alpha minus 1, alpha minus 2, alpha minus 3, and up to 1. So it is a multiplication, so it is factorial, alpha minus 1 factorial. Okay, so when alpha is a integer, then gamma function of alpha means what? Alpha minus 1 factorial here. Okay, so if I will write it here, if alpha is integer, then gamma function, oh, if gamma is integer, then gamma function of alpha is equal to alpha factorial. I don't know what is happening. Okay, I believe that everyone knows about the factorial, that we have to multiply up to the alpha minus 1, alpha minus 2, alpha minus 3 up to the initial point, that is the 1 here. Okay, so that we concept we are using here, expected value of alpha is equal to alpha beta, and the variance is equal to alpha beta square here. Okay, actually in the on campus we are doing the derivation of these formulas also. Okay, but because there is a little bit complications in the derivation, so somewhere we are avoiding it. Okay, because in the gamma distribution also you have to do so much integration by parts only, and that will be a lengthy process. That's why we are not doing it. It is not, we are avoiding this from your syllabus to derive these formula to calculate the expected value of x and variance of x also. Okay, so now we are just saying a one question. So you can see in the simple continuous distribution, so we have done the normal distribution, so at the time it is clearly defined, it follows the normal distribution. Okay, so now if it is given a normal distribution with these parameters, you can use direct formula and calculate the probabilities. Okay, how you can do it? By converting into the standard normal distributed random variable. So in that case also there is no need to remember the density function of a normal distribution. The mean and variance, you know, it is mean is mu and variance is sigma square. So there is no formula for the normal distribution. Definitely in the uniform distribution there is a formula we will see, and it's a very easy uniform distribution because it's a constant term, 1 upon beta minus alpha in the density function. So it doesn't depend upon the value of x. That's why it is known as the uniform distribution. No change according to the x. Okay. Now we are doing a one question for the gamma distribution. Same here in this particular distribution. It is given in the question that they follows the binomial this gamma distribution. Okay. So if a random variable x has a gamma distribution with alpha is equal to 2 and beta is equal to 3. Oh, alpha is equal to 2 and beta is equal to 3. Find the probability that the random variable will take a less value less than 5. So we are saying x follows the gamma distribution with parameter alpha is equal to 2 and beta is equal to 3. Clear? We have to find out the probability when x is less than 5. So by the definition of the probability, we can say x is less than 5 and it is starting from 0 itself, because in this case, in the gamma distribution, it is given that x is greater than 0. Okay, so 0 to 5 and fx dx. Okay, now what is fx? Fx, we are just going back. Fx is equal to 1 upon beta to the power alpha, gamma function of alpha, x to the power alpha minus 1, e to the power minus x by beta. Okay, we substitute the values here. 1 upon, so beta is what? 3. So 3 to the power 2 into gamma function of 2. Then we are just taking x to the power 2 minus 1, e to the power minus x by 3. Clear? So this is the density function. So it will become 1 upon 9. And gamma function of 2, it is integer, so it is 1 factorial. 1 factorial is what? 1. Okay, then we are just taking here x e to the power minus x by 3. Okay, so probability when x is less than 5, we can calculate 0 to 5, 1 upon 9 x e to the power minus x by 3 dx. We can take 1 by 9 outside, 1 by 9 outside, and we can integrate it by parts. So that is a simple integration that by parts you have to do. Do you remember it? Do you remember how to do integration by parts? Correct. Okay. So we are using here two functions. So this is the first function and this is the second function. Okay, so now we are just taking here the integration. So what we are taking 1 by 9 outside, first function as it is, second ka integration 0 to 5 e to the power minus x by 3 dx. Correct? 0 to 5 minus integration 0 to 5, and then first as it is, first ka differentiation and second ka integration 0 to 5 e to the power minus x by 3 dx and whole dx. Correct? So we are just saying here this is a whole 1 by 9 common x, and now this is the integration you are doing. So what is coming here? 3 with the minus sign, 3 e to the power minus x by 3, and the limit is 0 to 5. Okay, minus integration 0 to 5 and e to the power minus x by 3 with minus 3 sign into dx. Any doubt? So that is given here, that minus 3x e to the power minus x by 3, the range is 0 to 5, and 3 times we are just taking minus minus plus in this case, and 0 to 5 e to the power minus x by 3 dx here. Okay, now we can substitute the values here. When we are substituting 5, then some values there, and if we are substituting 0, it will become 0. So now we are saying 1 by 9 is common, so it will become minus 3 x, it's 5 e to the power minus 5 by 3, and after that minus of minus 0. Okay, minus this one part. So minus minus plus 3 common, and again we have to integrate it. So it will become minus 3 e to the power minus x by 3 and the 0 to 5. So when we substitute the values here, and we are getting this 1 minus 8 by 3 e to the power minus 5 by 3, and the answer is coming 0.498. Okay, everyone get it? Any query in this one? So here you have to do the integration by parts basically. Okay, next question. At a construction site, the daily requirement of NIS in metric tons is a random variable having a gamma distribution with alpha is equal to 2 and beta is equal to 5. If the supplier's daily capacity is 25 metric tons, what is the probability that this capacity will be inadequate to on any given day? It means what? Given any day, it is this capacity is inadequate, means the value is coming more than 25. Okay, requirement is more than 25. So it means what? X is what? The daily requirement. It follows the gamma distribution with alpha is equal to 2 and beta is equal to 5. Clear? Now we are finding the fx. Fx is equal to 1 upon beta to the power alpha, alpha factor gamma function of L, x to the power alpha minus 1 e to the power minus x by beta. Okay, x is greater than 0, alpha is greater than 0, and beta is also greater than 0. So when we are substituting this, beta is equal to 5, alpha square, gamma function of 2, x to the power 2 minus 1 e to the power minus x by 5. We fix the value of the parameter. So it will become 1 upon 25, gamma function of 2 will become 1, and x e to the power minus x by 5. Okay, now we have to find out the probability when x is greater than 25. So that is what? 25 integration from 25 to infinity, 1 upon 25 x e to the power minus x by 5 dx. Now again same by the parts we have to do it. So 1 by 25 is coming outside, then first integration, the second part of the integration, and then when we are simplify it, it is coming 6 e to the power minus 5, which is 0.04. Sorry, just give me a 1 minute. I am just going for drinking water. Just give me a 1 minute only. Why range is 25 to infinity? Here it's a question. You can see here that it is given 25, capacity is 25 and this capacity will be inadequate. So that's why it is 25 to infinity. Gamma function of 2, as I told you earlier also, if alpha is integer, then gamma function of alpha is defined as alpha minus 1 factorial. So gamma function of 2 is 1 factorial. 1 factorial is what? 1. Gamma function of 5 is equal to 4 factorial. 4 factorial means what? 4 multiplied by 3 multiplied by 2 multiplied by 1. Okay, Mr. Mahindra? Highlighted value is, you are saying gamma function of 2. Gamma function of 2 is 1. Got it? If it is not integer, that is a very big question. Actually, we have done, I mentioned here that gamma function of alpha is, we are calculating by this. So if it is not an integer, we are calculating by this integration, and it is not in your syllabus. We are not doing it is in so much detail. That is a gamma function. Okay, it is not in your syllabus gamma function. We are using the gamma distribution. Here we are using the gamma function. That's why this distribution name is gamma distribution. Okay. Now the next distribution is the exponential distribution, and exponential distribution is the special case of gamma distribution. So in the gamma distribution, if we put alpha is equal to 1, there are two parameters in the gamma distribution, alpha and beta. So if alpha is equal to 1, then we can say it is become an exponential distribution. So only one parameter is remaining. So you can see here that is gamma distribution, beta to the power alpha, gamma function of alpha, x to the power alpha minus 1 and e to the power minus x by beta. Okay, put alpha is equal to 1, so this fx will become what? 1 upon beta to the power 1, gamma function of 1, x to the power 0, e to the power minus x by beta. We can simplify it. We can simplify it. Just give me 1 second. Okay, we simplify it, so it is become 1 upon beta. Gamma function of 1 is again a 0 factorial, which is 1 only. Voice is not coming. How we can define this? One is, it is given in the question. Mr. Santosh, please check. Okay, it is given in the question itself. You can see the previous question. It is given in this one that it is a gamma distribution. Okay, in the previous question it is a gamma distribution. In the uniform distribution, it is given in the question that it is a uniform distribution. So there is no need to identify it. It is given in the question itself that it is a gamma distribution and uniform distribution. Clear? Okay, so 1 upon alpha, x to the power 0 is also become 1. So e to the power minus x by beta. So what we are saying here, that fx will become 1 upon beta e to the power minus x by beta for x is greater than 0, beta is greater than 0, 0 elsewhere. So when we are finding the CDF formula, you know, CDF is what? 1 upon that is f probability when x is less than equal to small x. So it is minus infinite to x fx dx. That we have done now. So that we are saying minus infinite to x ft dt, we can write like this one. So 1 upon beta e to the power minus t beta and dt. Okay, when we are solving it, it is coming here 1 minus e to the power minus x by beta. Just integration. So fx will become 1 minus e to the power minus x by beta, and mu is equal to expected value of x is equal to beta, and variance of x is equal to beta square. Why we can say? Because in the gamma distribution, expected value of x is equal to what? Alpha beta. Alpha is equal to 1, so it will become beta only. Okay, and variance of x, if you remember, it is alpha beta square. Alpha is equal to 1, so it will become beta square only. Got it? Any query in this one? Okay, this is the density function. You can see here for different value of beta. So we are getting a different form of the density function. Okay. Now one question we are taking here. Suppose the response time x at a certain online computer terminal. So response time, that is the elapsed time between the end of a user's inquiry and the beginning of the system's response to that inquiry. Okay, that is the response time, that they are starting and the user is ending their inquiry, and the system is responding. So that is the time that has an exponential distribution. So you can see in the question itself, it is given its exponential distribution with expected response time equal to 5 seconds. What is the meaning of expected time? That is the beta here. Okay, so we are just saying x follows the elapsed time, it follows the exponential distribution with parameter beta. And here it is given that beta is equal to 5 seconds. Because expected response time, it means what? Mean is given as 5 seconds. So beta is given as 5 seconds. Okay. So fx will become what? 1 upon beta e to the power minus x by beta. But x is greater than 0. Okay, na? That will become a density function. Now what is asking? The probability that the response time is at most 10 seconds. So probability when response time is at most 10 seconds. Okay, so it is starting from 0 because x is greater than 0. So 0 to 10, and the density function is 1 by 5 e to the power minus x by 5 dx. So we can say 1 by 5 multiplied by 5 with minus sign, and e to the power minus x by 5, and the limit is 0 to 5. So this is become minus 1, and the limit is become here e to the power minus 1 minus e to the power minus 0. So that will become here e to the power by minus 0 minus e to the power minus 1. And that will be e to the power minus 0 is 1. So it is 1 minus e to the, okay, I'm sorry. This limit is 10. Sorry. So minus 1. So it will become 10 by 2. 10 by 5 it is 2, and then it is become 0. So it is become minus 2 e to the power minus 2. And when we are just saying the answer by the calculator, it is 0.865. Zero to 10, because it is what? Probability x is less than equal to 10. 1 by 5 multiplied by 1 by 5. Why? We are doing the integration. So it is coming in the multiplication with minus sign. Huh. E to the power minus x by 5. So let minus x by 5 is equal to 2e. So what you will say? Minus dx is upon 5 is equal to dt. So you can say here dx is equal to minus 5 into dt. है ना? So it will become here e to the power t, and with minus 5 into dt. So that's why minus 5 is coming outside, integration e to the power t dt. Minus 5 e to the power t. Range, you can find out whatever the range of a to b. Okay, because of minus x by 5, it is the multiplication value. That's why I am using here this minus 5 as a constant here. Correct? Be careful about it. In the integration, you are not doing the derivation, you are doing the integration. Okay. Similarly, the next part is what? Probability. Second part, that 5 and 10. So 5 is less than x is less than equal to 10. Okay. That we can also do instead of using PDF, we can also do by the CDF. So in that case, what is the CDF? F of 10 minus f of 5. Exponential distribution CDF you know very well. That is 1 minus e to the power minus, you can see x by beta. So it will become 10 by beta minus 1 minus e to the power minus 5 by 5. Okay. So it is open it e to the power minus 2 minus 1 plus e to the power minus 1. So 1 is 1 cancel out. So it will become e to the power minus 1 minus e to the power minus 2. Open it. You will get the answer 0.2333. Is it clear? So this question also you can do it by using the direct CDF. So in the CDF it is what? F of 5 directly. F of 5 is e to the power minus 5 by 5. Oh, sorry, it is 10. I always f of 10. So it is 10 by 5. That is 1 minus e to the power minus 2. Direct by the CDF also you can do it. That's why in the exponential distribution I just mentioned its CDF is that. So there is no need to do the calculation for probabilities also. Directly by the CDF you can do it. But in the gamma distribution the CDF is very complicated. That's why I didn't mention. One more question. Try to solve it. Again I am giving the hint. So a server of a multinational corporate network can run for an amount of time without having to be rebooted. Without having to be rebooted. Okay. So it is a time is a random variable having the exponential distribution beta is equal to 3D. F of x is what? Probability when x is less than equal to small x. Mr. Bishnu, do you forgot about that concept which we have done? So probability x is less than equal to 10 means what? F of 10. So where x is coming there, that is 1 minus e to the power minus x by beta. So that is 1 minus e to the power minus x is become 10 and beta is 5. Now got it, Mr. Vishnu? So find the here it is x is the time without, oh sorry. Okay, so x is the x is the time is the amount without having to be rebooted. Okay, so it is a follows the exponential distribution. So x is what? The time without having to be rebooted. Okay, now x follows the exponential distribution with the beta is equal to 30. Now you can, yes, in question beta is given 30 days. Okay, now you have to find out this probability. I am waiting for your answer. Correct. Because what we have to find out, A part, probability when x is less than equal to 10 days. So this means what? Probability that is f of 10. Directly by the CDF we can say here. So in that case we can write it here. 1 minus e to the power minus x by beta. So here 1 minus e to the power minus 10 by 30. Direct fx you can use it. There is no need to calculate. Okay. The second part, at least 45 days. So probability when x is greater than 45 days. Okay. So that is what? 1 minus probability when x is less than 45 days. By the concept of the density function. So 1 minus f of 45. So 1 minus e to the power minus 45 upon 30. Open it, 1 minus 1 plus e to the power minus 45 by 30. Correct? Yes. Got it? So it's very easy. It is just a formula based. Definitely you have to remember some formulas, but the questions are coming formula based. You just identify the distribution. It is given in the question itself. So read the question carefully and then you just apply the formula, what is asked and what is given here. Okay. Next is exponential distribution and Poisson process. Poisson process you have done in the discrete case, the Poisson process. So exponential distribution is used in the combination of the Poisson process as well. Okay, so the number of failures NT which occurs in a computer network over the time interval 0 to t can be described by homogeneous Poisson process NT t greater than 0. Mr. Rohit, I can't say right now anything because we have a very limited time. Yes, you can use direct formula. Okay, for the practice session, I am trying to make some practice questions for you because in the last class you were saying that some practice questions you want. I am trying to make it. It is taking so much time actually, so I am trying to make it. I will just upload that. Ha, Sandeep, Mr. Sandeep. Okay, you just want a break? Okay, okay, just give me 2 minutes only. So I will upload on the Microsoft team about the practice problem. One PDF I will upload. So just give me about 2-3 days because right now we are also having the examination in the on campus, so that's why a little bit busy. But don't worry about it. I will upload the practice questions in. I will just put it at least 2 questions for each distribution. Just try to do it. What is the syllabus for EC2 up to the exponential distribution? After that, whatever today we will do, that is not coming in the EC2 here. Okay, so that actually in this one I just mentioned here the process, Poisson process, and the it follows the exponential distribution. Okay, I will upload in the eLearn portal also the practice problem PDF. Hint formula, you can use it, a formula actually, hint formula, because distribution name is given and you can just know the distribution. I will show you that one slide is given. You can just that summary sheet, and it is also given in your test book. Don't worry about it. Okay. And from that you can just find out which formula is applicable. It's up to you. That is the important part, that you have to identify that which formula is applicable in which question. If I will give that hint, so at the time of examination, you are not able to identify the formula. If I will give the hint of the formula, then what you will do? You just apply that formula and you can just do it. But that will not give you the practice actually. Okay. Okay, I will just take the break. After the break, we will start this. So here it is a combination of exponential distribution and the Poisson process. And this is the last topic of the EC2 syllabus. This is the last topic. Okay. Actually, class is not started, Miss Aruna. We are just discussing about the EC2. Yes, Mr. Rajesh. Yes. Yes, Mr. Rajesh, I allow you. Exponential distribution are can be used in the Okay, thank you. Okay. Exponential distribution is used in the combination of Poisson process. Poisson process you have done in the last chapter, because in that discrete case, okay, when x follows the discrete case. So what is the concept which we are using? If you remember, we are using the Poisson distribution. So what we are doing in that the number of events occurred in a particular time length follows the Poisson distribution. Okay, that you, if you remember, we have done the Poisson distribution. So Poisson distribution we have done in the three manners. If you remember, that first is by using the directly it is given, it is a Poisson distribution problem. Second, we have mentioned that it is a distribution of the rare event. Rare event means what? And in the binomial distribution, if in n is large and p is very small, so we are using here the Poisson distribution to approximate the probabilities. And in the third case, in the use of the Poisson process, that in the continuous interval, if events occurred, so these number of events occurred follows the Poisson distribution. Now, in this is a continuous interval. Okay, now we are talking about this first one. Okay, so this is a time lapse, this is the second event, and this is the time lapse, this is the third event, this is the time lapse. Okay, so this time lapse, because it's a continuous distribution and it follows the exponential distribution. Okay. So we are saying number of failures which occurs in the computer network time, the time interval 0 to t we are taking here. So it is like the 0 to t we are talking about, can be described a Poisson process and NT, because NT is what number of events occurred, and it follows the Poisson distribution. Okay, with rate of failure rate of lambda per unit of time. So the epoch time for the first failure is follows the exponential distribution. So this is the time gap if we are talking about. Let us suppose we are talking about this time gap from 0 time to first event occurred. So this is a random variable and it is a continuous random variable and it follows the exponential distribution. That's why I'm saying the Poisson distribution and exponential distribution, they are used in with the combination here. Okay, events occurred follows the Poisson process, and the even the time elapsed between the this event occurring, then it follows the exponential distribution. Okay, so mean and variance of the exponential distribution, we can say here uh, here we are just talking about, because we are saying x follows the exponential distribution with parameter beta. We are just saying x follows the exponential distribution with parameter beta. Now beta will become here 1 by lambda, and lambda is coming from the Poisson distribution, है ना? The rate. So beta is the in time and lambda is the per time, basically that events, number of events occurred per unit of time basically. Okay, so that is become the lambda per unit of time we are talking. So 1 upon lambda, it become beta, that is the mean of the exponentially distributed random variable. So x follows the exponential distribution. The expected value of x is equal to square root of variance of x is equal to 1 by lambda, which is equal to the beta. है ना, that we have done, that is equal to beta, and beta is equal to 1 by lambda. So here we are saying fx is equal to, till now what we have done, 1 minus e to the power minus x by beta. So beta 1 by beta is equal to lambda. So that's why it is become minus lambda x into. Okay, but lambda is coming from the Poisson distribution. So don't be confused that beta and lambda are different. They are coming from the same thing, that is beta is equal to 1 by lambda, or lambda is equal to 1 by beta here. Got it? Now one question we are doing, data collected from Toronto Pearson International Airport suggested that an exponential distribution with mean value of 2.725 hours is a good model for rainfall duration. Okay, that okay, there is a gap between the rainfall. Okay, and that is about 2.725 hours mean. Now what they are asking, what is the probability that duration of particular rainfall event at this location is at least 2 hours. So here it is a directly question that x follows the exponential distribution with beta is equal to 2.725 hours. And they are asking about probability when x is at least 2 hours. Okay, third is asking at most 3 hours, and the next one is asking 2 is less than x is less than 3 here. Okay, so this is the direct question of the exponential distribution. I believe that you can do it, है ना? We have done already one question. So it is probability when x is at least 2 hours means what? That 1 minus probability when x is less than equal to 2. So it is equal to 1 minus f of 2, and it is equal to the 1 minus e to the power minus x is 2, beta is 2.725. So that is equal to the e to the power minus 2 upon 2.725. Okay, next is what? Probability when x is less than 3, at most 3 hours. So that is what? F of 3 directly. So that is 1 minus e to the power minus 3 upon 2.725. And now probability of 2 is less than x is less than 3 between this. So what we will say? F of 3 minus f of 2. Yes, correct, Mr. Venkata. It is given mainly strictly, then we are taking axis between 0, 2 to 3 strictly, and otherwise we have to take equality sign. And in the continuous case, the answer will not affect here because the probability at one point is equal to 0. Hai na? So 2 is included or not included, it's hardly matter in the final answer. You can see this one, you can see this one, and these are the answer. Correct? This is the CDF, formula of CDF, Mr. Sanjeev. Fx is equal to what? 1 minus e to the power minus x by beta. Exponential, we are talking about here the exponential only. Yes, it matters in the discrete that we are including or not including. Okay. Okay, I didn't mention here the one question. Okay, I will do a one more question. I will do in the next class. I will just find out a one question from your textbook for the combination of the Poisson and this. Okay, for the Poisson and the exponential. If x to now the important thing is what? Memoryless property. Why we are saying memoryless property? As you are seeing in this one, in the exponential distribution, we are just saying here that time for first failure. So this is the first failure we are talking about. Now I am just saying about this one also, this one also, this one also. Why? So after event is occurred, then they are become they forgot about it. Okay, So now the time is started again at the initial point. So if x is to have an exponential distribution with rate parameter lambda, so you can see careful in the parameter form. If rate is given, then it is given in the lambda form, and if mean is given, then mean is what? Beta, and beta is equal to 1 by lambda. Be careful when we are just taking the parameter, okay, in the formula, because there are two parameters we are talking about in the exponential distribution, lambda and beta. So rate is lambda and mean is beta. Okay, rate we are talking in the term form of and mean we are talking in the beta, and beta is equal to 1 by lambda. Be careful about it. Okay, then it is a memoryless. Memoryless means what? That the distribution of a waiting time until a certain event doesn't depend on how much time has elapsed already. Okay, so then it is known as a memoryless. Got it? So what we are saying, for example, I showed you a picture of the fishing. Okay, so if you just pick up one fish, so there is a random time actually to pick up second fish. Okay, so it doesn't depend on how much time you have taken for the first fish. Clear? So that is independent of the second fish. When you are picking the second fish, similarly the third fish. Okay, so it doesn't depend upon the time you are taking in the first fish to pick the second fish. It doesn't depend. So they just forgot about the event occurred. After that they will start the initial level. So again it will start from this point, and again they will start from this point. So what is the gap here? They just forgot about it. That is known as the memoryless property. Okay, so x is greater than t plus t naught, given that t naught is already occurred. So it's hardly matter, it is directly x is greater than t. Okay, so we are just using this is the life length of a bulb. For example, life length of a bulb. Okay, so I don't know that it is already life. They just you can see that life is already gone. It is up to the 5 days, let us suppose. Okay, so it doesn't mean that okay 5 days occurred. What is the probability that it will just again that it will work, or it will the life is next 3 days. So it doesn't depend upon the last 5 days working, which we have already done. Okay, that is known as the memoryless property here. Clear? Any doubt? Any? So I am just doing a one question that is not on the slide, which I am just talking about the summary of some important distribution. You can see the binomial distribution, geometric, hypergeometric, Poisson distribution, its density function, its mean, its variance, its moment generating function. Okay. Similarly, in the continuous case, you can see uniform distribution, normal, exponential, gamma. So today we have done firstly we have done uniform distribution, then we have done the gamma distribution, then exponential distribution, and in the last class we have done the normal distribution. So these are the density function, these are the mean, this is the variance, and this is the moment generating function. Clear? So this is the summary, as I told you, to find out that these are the formulas. So when we are doing one by one, it's look very so much formulas, but now you can see here there is a very less formulas which we are using here. Otherwise we are using the concept. Okay, so you can also remember some CDF also. It's very easy. Okay, so you can use the CDF also. That is what x minus alpha upon beta minus alpha. In the normal distribution we are using the table. In the gamma distribution we are also not using it, and only 1 minus e to the power minus x by beta. Okay, and this summary sheet is also given in your textbook. Don't worry about it. Clear? So this summary is given in the form of discrete and continuous. The first one is for the discrete case, and the next one is for the continuous case. Clear? Now it's clear to all of you. Now just give me a 1 minute. I will just writing a one question. I found a one question for the this one. Huh. So I am reading the question. Actually, it is not on the slides. I forgot to mention on the slides. So I'm just trying to read it and I will just explain it. So later on, I will upload it on the slides. Okay. So now we are just doing a question. So the question is, I am just reading the question. Please try to understand here. The number of weekly breakdowns of a computer is a random variable having a Poisson distribution with lambda is equal to 0.2. Correct? So X is what? Number of breakdowns of a computer. है ना? Having a Poisson distribution with lambda is equal to 0.2 here. Clear? Now find a percent of the time that the interval between breakdowns of the computer less than 1 week. Okay, so what we are saying, X is the number of breakdowns. So we are saying y is equal to the time elapsed for first, or I will write like this one, time elapsed for first breakdown. And it is given in the week basically. Correct? So y follows. It is not given in the question, but we have identified because it is corresponding to the Poisson distribution. So it is exponential distribution with lambda is the same as 0.2. And we know is beta is equal to 1 by lambda. Because lambda is what? That is the events occurred per unit of time. And beta is what? Time. So that's why it is 1 by lambda here. And what they are asking? Probability, then y is less than 1. है ना, less than 1 week. So less than 1 week, y follows the exponential distribution with beta is equal to 1 by 0.2 here. Beta is 0.2. So that is what? F of y, or that is what? F of 1 basically. So by directly by using the CDF of the exponential distribution, 1 minus e to the power minus lambda x lambda y. Okay, instead of y by lambda we can use directly lambda also. So we can use it 1 minus e to the power minus 0.2 of y is 1. This is the answer. Okay, I will upload this question also on the slide and then I will do it. Yes, Mr. Rohit, this is the 9th session actually. That's why I'm saying that this syllabus is up, should complete within 8 hours, but we are going in a very slow pace. This is applicable for makeup examination. Correct. We are not changing the syllabus of the regular and makeup examination. Okay. Now come to the, that's why I'm saying I'm going very slow pace. I have to complete the syllabus. I don't know how we can just complete the syllabus at the end in the 16th session. And you are also saying for the revision session, is it not is it possible actually to take the revision? Try to do the questions your own. I will upload this practice type and you can discuss the questions with the solution also. Okay, now section 5.10, it is not in the syllabus of EC2. Joint distribution, again I am saying here. So joint distribution is the extension of the chapter 4 and 5, which we have done earlier. So, and the earlier we have done the single variable distribution. Single variable means x. We are talking about the x only. But here, if there are two variables, x and y, then we have to just move to the joint distribution. Okay. So experiments are conducted, more than one random variables are observed simultaneously in not order to determine not only their individual behavior, but also the degree of relationship among them. Okay, so a student is randomly selected from a class. The observation could be their gender, their height, weight, marks obtained in the probability and statistics course, and etc. Yes, I will share it, Mr. Vineet. I am saying that I am trying to make it. Give me 2-3 days also, because it is not done till now. It is not. I am started that working on it. I am working on it to make the practice questions. Okay. So there are so many, you can say, the parameters we have to consider. So there are so many random variables we are saying, and which we are just taking together. Okay. So as you know, height and weight we are taking together most of the time. And marks in the probability and statistics course and the other course also. Then only you are getting your CGPA. So that is the two different, you can say, random variables, and we are studying them simultaneously. Okay, for a new variety of seed developed in lab, the observation could be height of a plant, yield, tolerance to some stress, and etc. So there are more than two variables, or more two variables we are talking about, then we have to use the joint distribution. Okay, so in the joint probability distribution, we will discuss joint distribution, marginal distribution, dependence and independence of a random variable, that you have done in the earlier chapter 3, expectation, mean, and variance. Okay, so now we are doing the same thing. So firstly, the discrete case. So as we have done the chapter 4, the discrete single random variable, then we are just going for the discrete case. So for two discrete random variable x and y, now we are talking about the more than one random variable, and that we are doing for the 2, we can also extend for the 3. So we write the probability that x will take the value of small x and y will take the value of small y. So probability when x is equal to x and y is equal to y. So fxy can be written as probability when x is equal to x and y is equal to y is the joint probability mass function for x and y here. Okay. So for example, we are saying intersection. So you have done the two events A and B. So here density function, the fxy is what? Probability of A intersection B. Okay. That is very important. Here we are talking about the intersection point of two random variables or two random events. So that part you have already done in chapter 3. Now we are extending it with the combination of chapter 4, that is discrete case, in the probability density function, CDF, their mean, their variance, and so on. Okay, so we are just taking a one example. Roll two dice. Let x be the value on the first die and y be the value on the second die. So x is value on the first die, so it will be 1 2 3 4 5 6, and y will also 1 2 3 4 5 6. So these are the some values. Okay, so x and y takes the value 1 to 6, and the joint PMF is what? That joint PMF is what? That we are taking 1 by 36 here. Why we are taking 1 by 36 like this one? X is equal to 1 and y is equal to 1. This is a one combination. So you have done this a sample space. So how we can just make a sample space? All possible combination, 1 comma 1, 1 comma 2, 1 comma 3, and so on, 1 comma 6. Similarly, we are saying here. Okay, so there are total 36 points you are getting. Same question we have done in the form of events. Hai. So 1 1 is coming here, one combination with 1, so it is only 1 point, so it is 1 by 36 here. Similarly, 1 by 36, 1 by 36, 1 by 36, 1 by 36, when x is equal to 1 and y is equal to 6. So this is the probability mass function. So fxy always be greater than equal to 1, because you know very well probability density function always be between 0 and 1, and it is a discrete case. So summation should be equal to 1. So here there are two variable x and y, so we have to add it for this. So we are adding row wise and then we are adding column wise here. Okay, so random variable for x y's and random variable for y. So we are doing these things, and that is become 1 by 36. So you can see these are 36 values and 1 by 36, so their summation should be equal to 1 here, and all are greater than equal to 0 and between 0 and 1. So that means it is a joint density table. Okay, so this is the way to rewrite the density function, and be careful that we are talking about intersection here. Okay, that and the term is 1 and 1 here. And another example we are taking here, again roll a 2 dice, let x be the value on the first die and t be the total on the both dice. Okay, so x be the value on the first die. This is same, x can vary from 1, 2, 3, 4, 5, 6. But t is not like this. T is what? If x is equal to 1, then it will start from 2 and 2 up to the 7. है ना? So that's we are saying t is starting from 2, 3, 4, 5, 6, 7 up to 7. Yes, correct, Mr. Vishnu. Actually, in chapter 4, if you are just mentioning, so you are mentioning the x and you are defining the fx. है ना? 1, 2, 3, 4. And you are writing 0 0.3, 0 0.1, 0 0.05, 0 0.55, and so on. So same table we have to make. This is a one-dimensional table. Here it is a two-dimensional table because there are two random variables. Okay, so now we can say that t, what is the possible values of capital T? What is the when x is equal to 1, so t will be 2 to up to 7. After that it is 0, 0, 0, 0. Okay, when x is equal to 2, so at the time 2 is not possible. Q, 2 dice will be 6 plus 6. Mr. Sanjeev, what we are doing here? We are saying x is equal to already 1. So total dice can be the second one. What is the second one? It may be 1. We are just taking like this one. Y is equal to 1, 2, 3, 4, 5, 6. So what is the t? T will start from 2, then 3, then 4, then 5, then 6, then 7. So these are the possible values of t when x is equal to 1. Are you getting, Mr. Sanjeev, here? Similarly, when x is equal to 2, so y is equal to 1, 2, 3, 4, 5, 6. So what is the value of t? So it will become 3, 4, 5, 6, 7, 8. Yes, correct. You can see it will is shifted. Then x is equal to 3. It is 0, 0 and it is shifted. Correct? So this is the joint table here, and you can say the combination is what? 1 and 2, 1 and 3, 1 and 4, and that all values are 1 by 36. So here the density function, we can say here it is 1 by 6. So x is equal to 1 and t is equal to 2. The probability is what? 1 by 36. Probability when x is equal to 4 and t is equal to 9. What is this? 1 by 36. So x is equal to 4 is this, and t is equal to 9 is this, and we are talking about this 1 by 36. Correct? So event is what? Is a subset of the sample space, you know very well. So we are defining in the first example, when x and y we are talking about b, that is the y minus x is greater than equal to 2. So B is the event here. We are talking about 1, 3, 1, 4, 1, 5, 1, 6. Correct? That is more than 2. Y minus x is more than 2. 2 by 4, 2 by 5, 2 by 6, 2, 3 by 5, 3 by 6, 3 and 4 by 4, 6. These are the possible values. So in the complete table, these are the values which is define the event B. So we are just adding 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's why it is 10 by 36. So we can find out the different type of probabilities, whatever it is required from this density table. Clear? Any values of the we can define as the event, and then we can find out the probability of that event by using this density table. Okay? Is it clear to all of you? Then we are finding the marginal density function. Okay, that we will discuss in the next class. Time is almost over, so I am just stop here. ठीक है?